Unit 4, Part 3, Analytic Geometry, Conic Sections, Ellipses, and Circles. So we've talked about parabolas, we've talked about hyperbolas. The last conic sections we're going to deal with are basically round. We've got circles, or a stretchy circle that's stretched one way longer than the other is an ellipse. Ellipse is what we've called for years an oval. If you look at the conic section, if you slice a cone horizontally, you get a circle. If you slice it through a plane with a plane at an angle, you get an ellipse. Well, the main difference here, if you remember on hyperbolas, we did c squared is equal to a squared plus b squared. Well, now we're going to do c squared is equal to a squared minus b squared. And for eccentricity, if e is less than 1, we're dealing with an ellipse. If e is equal to 1, we're dealing with a circle. And for a circle, well, for an ellipse, we're still going to do just like we did with the hyperbola. It's going to be x minus h squared and y minus k squared over a denominator. So one's a and one's b. And it's a plus then between this time. And then it's equal to 1. Well, if a and b are the same value, then it's a circle. If a and b are different values, you go this way a and this way a, and then this way b and this way b. Well, if a and b are different values, then it's an ellipse. If a and b were the same value, it's always a circle. And let's see, you might need the distance formula to find the length. So sometimes they'll give you a diameter, and or a radius, and we can use distance formula to find that length. You might need them, if they gave us a diameter, you might need to find the midpoint so we can find the center of a circle. And once again, we're still going to use the vertices and the foci. Just don't worry about trying to memorize the formula. Think of the foci are always on the main axis, and the main axis is always the bigger one in ellipse. This one, because it's both positive, on a hyperbola, it was easy to tell. The main axis always had a positive value with it. This one was positive and the other one was negative. But on an ellipse, they're both positive, so it's positive and positive. And so we look at the main, whichever one is bigger is the main axis. Whichever one's smaller is the minor axis. See, this one had the focus, the two foci will always be on the major axis. So let's kind of let this sink in by practicing these. So let's move to, moved a little too far, to number 1. So the center of the ellipse is going to be at 2, 0, x minus h, y minus k. So 2, 0, there's a center. This says under the x, we're going to move the square root of that. We're going to move left and right 6, since that's all. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And under the y, we're going up and down, we're going to move the square root of that. We're going to go up and down 7. So 1, 2, 3, 4, 5, 6, 7. And then down 1, 2, 3, 4, 5, 6, 7. Unlike on a hyperbola where you drew a box, you just make the oval. Whoops, my finger touched the inside, sorry. There's our ellipse. On the next one, if we divide both sides by 125 to get it equal to 1, you'd get the same denominator. 5 goes in 125, 25 times. So we have x minus nothing over 25 plus y minus nothing, I forgot to say squared, over 25, it's equal to 1. So you could either leave it x squared plus y squared equals 25, or this tells you go under the x, go left and right, square root of that. Under the y, go left and right, up and down, the square root of that. Or this is your radius, the square root of that. So the center is at 0, 0, because there's no h and k. And we're going to go left 5, 1, 2, 3, 4, 5. We're going to go up 1, 2, 3, 4, 5. We're going to go right 1, 2, 3, 4, 5. And then down 1, what's that? 1, 2, 3, 4, 1, 5. And then down 1, 2, 3, 4, 5. And then you draw the best you can a circle. And the radius was 5. On number 3, if we divide both sides by 144 to get this equal to 1, well, 36 times 4 is 144. So 4 goes into 144 36 times. So x minus 3 squared over 36 plus y plus 1 squared. 36 goes into 144 4 times. And now it equals 1. So my center, h comma k, is 3 comma negative 1. 1, 2, 3, negative 1. There's the center. Under the x goes 6 left and right. So 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And up and down, the square root of that, up and down 2. 1, 2, 1, 2. And then we draw our oval. There is our ellipse. Now it says find the center radius form for a circle that has endpoints at -4, 6. So 1, 2, 3, 4, -4, 1, 2, 3, 4, 5, 6. And then 0, -2. There's the endpoints of the diameter. So my circle is going to be somewhere like, kind of like that. I didn't draw it very well. But we know what the diameter is. So now we need to find the length and find the middle. So the center is going to be midway between those two. So let's find the center first. I'm going to do that. The center is going to be the midpoint. To find the midpoint, add the x's and divide by 2. -4 plus 0 divided by 2 is -2. 6 plus -2, 6 plus -2 divided by 2 is 4 divided by 2 is 2. So -2, +2. Yep, that looks pretty good. I did pretty good finding the center. So now I know my formula is going to be x minus -2 squared plus y minus 2 squared is equal to my radius squared. I don't know the radius yet. Well, we know the diameter. The radius is half of that, so I just need to find out what this length is. So distance formula says, and you could do Pythagorean theorem. If you don't like distance formula, draw a right triangle and do a squared plus b squared, and you can find out what c squared is. But that's all distance formula is. Distance formula says take -4 minus 0, which is -4 minus nothing, you square it, plus, is that a 6? 6 minus -2. 6 minus -2 is 6 plus 2 is 8, and square it. You take the distance, the difference between those two, and that's 16 plus 64, which is 80. So the diameter is square root of 80, which is 4 times 20, 16 times 5. So 16 times 5, and we know the square root of 16 is 4. So 4 square root of 5, 4 square root of 5 is the diameter. Well, the radius is half of that. So the radius is 2 square root of 5. So this is 2 square root of 5. And 2 square root of 5 squared is 4 times 5. When you square 2, you get a 4. When you square a square root, you just get that number 5. So 4 times 5 is 20. So the center radius form is x plus 2 squared plus y minus 2 squared is equal to 20. And find the center radius form. So yeah, we are done with number 6. On number 5, to find the center, vertices, and foci of the given ellipse. So this one, x minus nothing, so h is 0, k is 3. So the center is 0, 3. Well, for the vertices, you look at which denominator is bigger, it went up and down 5. The y value underneath the y was at 25, so that number, the square root of 25 is 5. So I want to take this and go add 5 and subtract 5. So my vertices, if you take from 3 and add 5, you get 8. And if you subtract 5, you get -2. The co-vertices, if we wanted, is how far we go left and right. That's going to move, because that number, the square root of that, so it's going to go, the co-vertices, didn't ask for it, but we're going to practice that. When you go left and right 2, we still stayed 3, but if you go left 2 and right 2, that's -2, 3, and +2, 3, but they didn't ask for co-vertices. What else did they ask? Center vertices and foci. So to get the foci, we need to do, instead of c squared equals a squared plus b squared, it's a squared minus b squared. In this one, a squared has to be the bigger value. So 25 minus 4, which is 21. So c is equal to the positive or negative square root of 21. And c is always along the major axis. So the major axis with the bigger value, so it's up and down. So we're going to go 3, so 0, so the foci are 0, 3, plus and minus the square root of 21. From 3, go up square root of 21, down square root of 21. And there's our foci. Center, versus, we're done with number 5. Let's move on to number 6. On number 6, this one is a little more complicated. It's not in any form that we recognize right now. It's going to make us review some factoring traits. So I've got x squared minus 6x plus blank. We're going to complete the square. Plus y squared. There's no extra y terms, so equals, I'm going to put the 89 over here on the other side for right now. And since we added something here, we're going to add something here. So let's complete the square. So take half of that term and square it. So half of 6 is 3. 3 squared is 9. So I'm going to add 9 and subtract 9. And then that factors to x minus 3 squared. It's half of this term, or the square root of this term, plus y squared equals negative 80. So now, the center of this, if it were a circle, would be at 3, 0, because h and k are 3 and 0. But the radius is negative 80, or square root of negative 80. So square root of negative 80, this is not a real circle. It's not possible. So this one's not possible, because this is a non-real value. Not possible. Okay, let's move on to number 7. An ellipse with a major axis from negative 4, negative 4 to 8, negative 4. So we went from negative 4 to 8, which is 12 units away. And then the minor axis, and if you notice, those x values changed, so that the x went 12. The minor axis went from 2, negative 6 to 2, negative 2, so that went 4 away. So that means, what do we know? We know, well, the center has to be halfway between those values. And one little hint here, to find the center, look at what didn't change. The x's stayed at 2, and this one, the y stayed at negative 4. So the center is at 2, negative 4. Or you plot those points and go halfway in between, plot those points, go halfway in between, you'll get this center of 2, negative 4. And let's see, what do we know? We know all the way across was 12. Well, that means our major axis, if the major axis is 12 all the way across, from our center to the edge, it'd be 6. So A is equal to 6. And the minor axis is 4 all the way across, so halfway across is 2, so B is 2. So if we write our equation, we have x minus 2 squared plus y plus minus negative 4, so y plus 4 squared equal to 1. And our major axis, the x is changed, so it goes into the x. So 6 squared is 36. The minor axis with 2 squared is 4. And there's our answer to number 7. We had to figure out how much it was all the way across. But remember, if you're going all the way across, there's the major axis. If that's 12, A would have to be half of that, which was 6. And if B was 4, or B squared, the whole term, if it was 4 all the way across, then that tells me that's 2. So B squared would be 4. Okay, number 8. Let's practice that factoring, that completing the square again. So we have x squared minus 6x plus blank, plus y squared plus 4y plus blank equals 10. And now let's look at what we add. We're going to take half of 6 is 3. 3 squared is 9. So I'm going to add 9 over here. But then also, half of 4 is 2. 2 squared is 4. I'm going to add 4 over here also. So now we can factor the left. This factors to x minus 3 squared. Plus, then we can factor the right. This factors to y plus 2 squared. And then equals, well, 10 plus 4 is 14 plus 9 is 23. So now I know the center is HK, so 3, negative 2. And the radius, that's the radius squared, so the radius is the square root of 23. We don't worry about plus or minus because we only want the positive radius. And so there is number 8. Let's move on to number 9. Well, whoops, sorry. I clicked on the wrong. On number 9. So let me scroll this a little more. Okay. On number 9, find an ellipse with the x-intercepts at positive negative 7. So it went left 7 and right 7. And the foci were at left 6 and right 6. So let's kind of look at what's going on here. We went 7 this way and 7 this way, and then 6 and 6 inside there. So we know the center is at 0, 0. And my major axis was 7 and 7. So we know it's going to be x minus nothing squared. So x squared over 7 squared. And then plus y squared over some number squared is equal to 1. Well, we know that a was 7, not a 1. But the distance to the from the center to the focus was 6. From 0, 0, 0 to 6, 0 was 6 away. So c was 6. So if we do a squared minus b squared is equal to c squared, we're going to do 49 minus b squared is equal to 36. So if I move the b squared over the other side and basically make that 49 minus 36 is what b squared would be. 49 minus 36 is, what's that, 13? So b squared is 13. And we're through with number 9, the first number 9. Let's look at number 10. On number 10, an ellipse with foci at -4, -2, and 2, -2. So the major axis has a length of 10. So that means A has to be half of that, 5. And let me make a little sketch. It makes it a little easier for me to talk about. We went -4, -2, and +2, -2. Those are where my foci are at. So my major axis has to be down here. And the center has to be halfway between those two. Well, what's halfway between -4 and +2? Well, -4 plus 2 divided by 2 is -2 divided by 2 is -1. So the center is at -1, -2. So, and it's x minus -1, so x plus 1 squared over something, plus y minus -2, so y plus 2 squared over something equals 1. We know the center is horizontal because we went left, because they told us that the foci were on a horizontal line. So that means a is underneath the x, so 5 squared would be 25. And what else do we know? We knew c. C was, how far did it go from -1 to -4 or -1 to 2? Either way you look at that, we went 3 away. So c was 3. So if we take 25 minus 9, for a squared minus, or c squared minus a squared, which way did I do it? C squared minus a squared. 25 minus 9 is 16. So b squared is 16. And there's number 10. Let's move on to number 11. An ellipse with the center at the origin. The major axis is 12, so that tells me a is 6, because that's 12 is all the way across, a is 6. And the x-intercepts are up and down 2. So b was up and down 2. So if it's at the origin, it's x squared over, and x squared and y squared without any h's and k's, sorry, with a plus. We went left and right 2, so that's 4. We went up and down 6, so that's 36. Okay, we're through with number 11. Now, number 12, a rectangular board is 6 by 18. How far from the center of the board will the foci be located to determine the largest elliptical tabletop? So basically, we've got a board that is, the longer one's 18, that one's 6. And we want to make the largest ellipse we can out of this. We want it to go like this. So the major axis is 18. No, the whole thing is 18. So so the major axis is 18, yeah. So that means A has to be 9, half of that. Well, the minor axis is 6, so that means B has to be, half of 6 is 3. Well, C is where the foci are going to be. So if we take A squared minus B squared, that is 81 minus 9, which is 72. So c squared is 72. So where would c be located? The square root of 72. And that's what, 9 times 8. And I know that's 3. And that's 4 times 2. So that's a 2. So 6 squared of 2. Oh, 36 times 2. So yeah, 6 squared of 2 is the non-decimal version. The decimal version, if you use a calculator, that should be about 8.5. So about 8.5. And that's where our focus would be for this ellipse. Okay, that's everything you need for this assignment. Good luck to you.